exploring objective is to be able to find the intersection points using a graphing calculator. So the first problem looks like this. And it's already made it easy for us because we have y equals in both positions. So hit y equals, and I forgot to clear the last problem, so let me do that. Y equals, and we're going to type in x squared plus 3x plus 1. Then I'll go to the next equation and do negative, not subtract, negative 2x plus 1. So I have a quadratic equation that's opening up, and I have a linear, which is a straight line that has a negative slope. Hit graph. Remember, your solutions are the locations in which they intersect, and each solution will have an x and a y point. So I can see one answer here, but does everybody see up here where I can see that they're eventually going to cross again? So think of this as a curtain. It'd be nice if I could roll this curtain up a little higher. So this is the y direction. I want to go upward in the y direction. So hit Windows, go to your y maximum. We want to go upward. It's only right now, so we have a maximum of 10. Let's go up to 20 and hit graph to see if we can now see the second intersection point. Okay, so how do we find intersection points using the graphing calculator? Hit second trace and go to intersect. Second trace, intersect. Okay, so I'm going to use the cursor here, and I'm going to go a little bit off to the left. And this says, right now, it says first curve. First curve just refers to one of the equations. It doesn't matter which equation it is. So first curve right now is referring to the first equation we entered, which is the parabola. So I press enter one time, and now it jumps to the second equation, which is the linear line, and it's the second curve. We press enter again, and now it says guess. So go over the top of where you think they intersect and press enter. We have nice integers. We don't need to round to the nearest tenth, so we know that one intersecting point is 0, 1. Let's find the second intersecting point. Second trace intersect. Second trace intersect, and I need to use these cursors to move closer in the position to where they're going to intersect. So first curve just refers to the first equation we put in, which was the quadratic equation. So it's near the intersecting point, and I'm on the first curve. I press enter. It automatically jumps to the second curve. I press enter again. Then I go over the top of the intersection, and I press enter once again. It's nice because I don't have to round to the nearest tenth. They're nice integers. The second intersecting point is negative 5, 11. So I just want to show you something. Since we have nice clean points, can everybody do second graph? So we're going to look at the table. This is your first equation, which is the quadratic equation. This is the linear equation. So if we look here, there's only two places we can see where when I have an x value of 0, both of them have a y value of 1. That's one point. Keep going down. And here's the second point at, oops, I have to go the opposite direction, at negative 5, 11. Negative 5, 11. So in the past, I believe you may have been taught your freshman year to look at the table to find the intersection points. That works when they intersect at nice integers. But if they intersect at decimals, this doesn't show up where decimals intersect, only where integers intersect.